Hello. So now in this video we are going to discuss the Verilog code for T-Flip-Flop and also the simulation using model sim. So here we have the module defined here as T-Flip-Flop, and the flip-flop has two outputs. One is a true output, other one is a complement output. And the true output is going to be the target signal inside the always block, so it is defined as a reg data type. And now the T flip-flop is having T input mainly and the clock input. But in addition to that, there is an additional input that we are using it here called a reset signal, or we call it as an asynchronous input. Then we have here the always block. Inside the always block, when the reset is 0 and Q will be set to 0, else depends on the T value. If T is 0, Q will be the previous value, and if it is 1, and output will be the complement of the previous state. So that's going to be the toggle condition for the flip-flop. And to get the values updated for the complementary, so here we have the conditional statement defined here in line number 2. QB is equal to not Q. So that's the Verilog code. Now we will go for the simulation of this. So as we go for the simulation of this, here we here we find those signals over here, and now we will just add to the wave, and now I move all these signals to the top, all my inputs. Now I set the reset at the beginning. Then now I set initially the reset with the force value 0, and the T I will just set normally with the 100 and pressing edge. Then we will have the clock that is set with the clock period 25 period and rising edge. So we are going to now run. So irrespective of the clock, the asynchronous inputs makes the Q to be with the value 0. And after a while, next what we'll do, we'll change the reset to 1 here. When the reset is set to 1, then flip-flop will start functioning, and as the flip-flop start functioning, it will be able to provide the necessary output. So here, this is the output over here. So until this point, the reset is 0, so the output is also 0. So now here we are going to select the clock, the positive edge of the clock. Now reset is 1, and now T is also 1. When the T is 1, so the previous state was Q was 0. Now it is toggled to 1. So then when it comes to the next positive edge, again the T is 1 at the positive edge, so it is changed from 1 to 0. Then in the next positive edge, T is 0, so it maintains the previous state. And similarly, it's a 0 maintains the previous state, and the next positive edge T becomes 1, and it is toggling. So this is the performance of the toggle flip-flop. So whenever the T is equal to 1, the output is toggled, and also we'll get its complemented version from in the Q bar output. Thank you.